Okay, so far we've learned a lot about solids. Most recently, probably just learned about surface area. Now we're going to learn about volume, and just to make you feel a little better, it's probably a little easier to find the volume of most polyhedra or solids than it is to find the surface area. So that's good, right? Alright, so what is volume? It's the number of cubic units contained in the solid's interior. So just like you measure length in units, like little, inches or centimeters, or surface area are squares that would cover the 3D solid. Volume is how many cubes you could fit in the solid. So you can think of like how much water would it take to fill the solid. That's the volume. You already know how to calculate the volume of rectangular prisms, alright? That would be like a box or something like that, and you do length times width times height. But what about other types of solids? So first let's look at something called capillaries principle. So if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So that means that cube on the left would have the same volume as that prism on the right, as long as they have the same base area. So that cross-section you could see is labeled as B on the left and also B on the right. If that square and parallelogram have the same area all the way through the solid, and the solids have the same height, they'll have the same volume. So the volume of a prism formula is just area of the base times the height. B is the area of the base. H is the height of the solid, so the distance between the two bases. So since it's a prism, the bases will be parallel, so you'd find the perpendicular distance between those bases. And the way I think of what's called like an oblique prism, like this prism on the right here, on the left it's a right prism. It's like a stack of CDs. So I'm kind of eyeballing it. Both stacks have about 17 CDs on them. On the left, it's straight up, so it's like a right prism. On the right, it's oblique because it's kind of tilted. But both of those prisms, represented by the CDs, have the same volume. Now the units we can measure those volumes are by CDs. On the left, it has 17 CD units of volume. On the right, it has also 17 CD units. So as long as they have the same base, so both CDs have all the CDs have the same area and the same height, then those two stacks will have the same volume. So let's find the volume of a non-rectangular prism. So this would be a right triangle prism. So we're going to find the area of the base. Now how do you know which one's the base? It's the faces that are parallel to each other. So this triangle and that triangle, if you extended it out forever, they would have the same, they would be the same triangle. Alright, the height would be 17. So we're assuming that the bases are congruent here. So that hypotenuse would be 26, because that's 26. That's 10. So to find this side, you could do the Pythagorean theorem. X squared plus 10 squared is equal to 26 squared. If you know your Pythagorean triples of 5, 12, 13, if you know that's a Pythagorean triple and you double all them, so you find a multiple of it, alright, we can also just figure out that x is equal to 24 that way. So when we're finding the area of our base, since it's a right triangle, the legs are 24 and 10, that'd be the base and height of the base. So you divide by 2, and you get 120 square units as the area of the base. Then, for the volume, we're going to do area of the base times the height. Now we're taking an area in square units times a height in units, so the volume will be in cubic units. So now you just multiply these numbers together, and you get 2,040 cubic units is the volume of the right prism.